Hello everyone, a very warm welcome to this another session of AIATS Plus 2025 Phase 2 program, and yes, this is the mock test number 6 which was conducted on 23rd of February 2025. I'm Chemistry Faculty Nidhi Panwar and I'll be taking the questions and the important concepts from the chapters, some basic concepts of chemistry, the very first chapter, then I'll be taking structure of atom as well, periodic classification, and some of the questions from chemical bonding as well as chemical kinetics. So these are the 4-5 chapters, those we are going to consider here in this session, right? So first of all, I just want all of you to get joined there so that I can begin with the session with the questions from this important AIATS Plus program, the program which is aligned for the personalized learning for ultimate success. Why we are considering this name? Because this is the time when the preparation is towards the last segment where we are revising the concept. So in this series, the questions we took on the pattern of the NEET, and with respect to that, you have plenty of the questions, plenty of the concepts which you can revise with the help of this series, right? So those who are the participant of this program, definitely it is beneficial for them, but those who haven't participated there, but still the paper is here and we are the faculty from the Aakash Institute here to help you out, right? So what I'm looking at, that people started joining. Gaurav, I'm able to see here that Gaurav has joined, and hope others are also ready to join, I should say, right? A very good afternoon everyone. Post lunch, sometimes it is difficult to continue with study, but this is not that part. I'll be here with several concepts. I'll be helping you to solve the questions, right? So don't worry, don't think that it's a burden this time, because this is the time when revision is very important, and if you just take part here in the discussion, you will find that it is helpful, right? So I am going to start the discussion. What I'm going to take here, first of all, the question, I hope it is visible, so I'll be here. See, the question is mass of water produced on mixing 2 gram of hydrogen and 8 gram of oxygen, right? So question, the simple question from the basic concepts of chemistry, the very first chapter, simple to say this is the question from the stoichiometry, right? In the stoichiometry, what are the key things, those you need to remember? First thing, that you have to just look at the reaction which is going on, balance that reaction, compare the moles of reactant just to identify the limiting reagent. And as you know that this is the limiting reagent which is limiting the reaction, that will help you to find out the amount of the product in a reaction, right? So this is the sequence that we need to follow. What we should do, let me just mark here, just give me a moment, I'll be taking pen from here. Yeah. So the first thing, we are moving with stoichiometry, right? And just to identify the stoichiometry, you have to just look at the chemical equation, right? And that chemical equation should be balanced chemical equation, right? Now with the help of this, you just compare the moles of reactants. Now there must be a question that why we are comparing the moles of reactant, just to identify the limiting reagent. So if some student are there from class 11th also, they would identify that this is very simple process, but you need to know the steps to follow, right? So identify limiting reactant or the reagent, and if one reagent is the limiting reagent, then definitely other would be there in excess. In a particular reaction, there would be one limiting reagent only, right? So identify the limiting reagent, and this limiting reagent will decide the amount of the product formed, right? So find the amount of product. So NEET 2025 aspirants, you all know that this is the simplest thing in the chemistry, that that type of question if comes, then +4 marks are sure shot there. right? Now just look at the question. Mass of H2O produced on mixing 2 gram of hydrogen and 8 gram of oxygen. So it's pretty clear that using hydrogen and oxygen, what you are going to do? You're preparing water. Definitely these two are mixed and exploded further because large amount of energy is needed in this process, right? We have to balance this reaction, and the simplest reaction, one of the simplest reaction from the chemistry can be balanced this way. Done. Now what outcome from this equation you can get from here? Just check. So if you just look at here, you find that 2 mole of hydrogen are reacting with 1 mole of oxygen, isn't it? Right? So when this happens, mass of water produced you need to find out, but you have the two values here, that 2 gram of hydrogen and 8 gram of oxygen. How much hydrogen you have? 2 gram. How many moles? Very good afternoon. So those who have joined here right now, the information for them is that we are discussing AIATS plus phase 2 program, where we are with the paper number 6. Mock test 6 we have here, and in which lots of questions with respect to the NEET syllabus are there, and I am taking some of the chapters from here, in which the first chapter from the chemistry part is some basic concepts of chemistry, from which I have just taken this question, right? And this question is from the stoichiometry, first to find out the limiting reagent and then to proceed for the identification of the amount of the product, right? So this is something that we need to work on. And the question is pretty simple, that an equation you can prepare, write with the help of this. You are not preparing, you are writing the equation, because hydrogen and oxygen is given to you and what is being produced, right? This I did. And what I am doing now, I am comparing the moles with respect to the stoichiometry and with respect to the given amounts. So how much amount of hydrogen is given? 2 gram. How many moles of hydrogen would be there? Let's do it here. Moles of hydrogen gas. 2 is the given mass by molar mass of hydrogen, that is 2 gram per mole. It means 1 mole is given, right? And what about oxygen? Moles of oxygen, given amount is 8 gram. And what's the molar mass? 32 gram per mole. So this is 1 by 4. So that is the data which is given. This is the reaction stoichiometry, and with the help of that, what we identified, that 2 mole requires 1 mole of oxygen. 2 mole of hydrogen needs 1 mole of oxygen. Very good afternoon everyone who have joined right now. The information is that we are discussing AIATS plus program, question number 46 from the paper, mock test number 6 I should say. Done. And let's solve this, okay? And I just hope that all of you are quite capable to solve this question. 9 gram, right Jaydev? But have a look on the question, right? So with respect to this, what I identified, if I have 1 mole of hydrogen, then 0.5 mole of oxygen is needed. Simple unitary method. For 2 mole, 1 mole is needed. For 1 mole, it means you did half of it. So half of this is needed, right? Half of the oxygen. But what's the amount of oxygen available? Is it 0.5 mole? No. The available amount is 1 by 4 or 0.25 mole of oxygen, right? So available is less, required is more. It means, what is the limiting reagent? Option 3 maybe, okay. So what is the limiting reagent? Undoubtedly, oxygen is the limiting reagent, right? So if I'm just looking at limiting reagent, 1 mole of oxygen is producing 2 mole of water. So if you have 0.25 mole of oxygen, then how much water would be produced? Double of it, just see, 1 mole is producing 2 mole, so double of it is 0.5 mole of water. Though this question is pretty simple, but this will give you an idea that such type of question, if you find in your examination, how to deal with it, right? In this question, they can even ask you that what is the excess reagent here. So excess reagent is undoubtedly hydrogen, and what is its amount which is present there in excess? That can be another question, right? So how to solve this? So whatever be the amount of hydrogen is used in the reaction, the remaining is in excess, right? So let's first solve this question. So 0.25 mole of oxygen is producing 0.5 mole of water. Done? So what's the mass of water? Jaidev, you just mentioned. What's the molar mass of water? How to find out the mass? Mass is moles into molar mass, right? So 0.5 mole and the molar mass of water is 18 gram per mole, right? So this is 9 grams. So absolutely right. Those who have marked here, Divya, Sudeep, Ronak, everyone who have identified the answer, thumbs up to you all. Very good afternoon. Those who have joined late, the question is in front of you. I just solved this question on the basis of reaction stoichiometry. The steps which I followed here are this, that I was just looking for the stoichiometry. Further, I just looked at the balanced chemical, because stoichiometry if I'm just looking at, then definitely I need to look at the chemical equation. And that chemical equation should be balanced. That will give me an idea that how many moles of reactant are combining together and how much product is formed in the terms of mole, right? So the number with the balanced chemical equation which we are using, those are known as stoichiometric coefficient. That stoichiometric coefficient tell us that what would be the ratio of reactants and the product. So everyone, very good afternoon once again. So those who are joining late, for them, very good afternoon. Question was in front of me, you all. I'll be just showing you, don't worry. But the steps we followed, that we were comparing the moles of reactant, identified the limiting reagent, then we found the amount of the product in this question. So have a look on it and allow me to proceed further. In this question, with the help of reaction stoichiometry, first of all I compared the moles of reactant to identify limiting reagent, and further I proceed with the final amount of the product, right? Okay, so I'm moving forward with the next question. But before that, as I've just told you that on the basis of stoichiometry, every time you find question in your NEET examination, so though it is easy, but practice is still needed, okay? Now, the question number 47 we have. Which among the following electromagnetic radiations has minimum wavelength, right? So if you just look at the radiations, radio wave is here, gamma rays, microwaves and the UV rays, right? In the second chapter, the various radiation and their wavelength and frequency order is given. I hope you all are able to recall. Jaidev and Hema Malini, wow. So those you are all are writing. Divya also wrote here the second option. So that's great that you, Archana, option 2, okay. So how to recall that order? So you can make your own mnemonic for that. One mnemonic I have for you, I have already written on the board. Have a look on it. Maximum for radio, great. So this is the order that I have here, just have a look on it. See, so I have this mnemonic here. This is ready for the mic testing with irritating and very unpleasant xylophone and guitar, right? Now this R is representing radio waves, first long radio waves, then short radio waves, done. Then further we have microwaves, the irritating is aligned with IR. Further we have the visible one, then ultraviolet, X-rays and the gamma rays, right? And this is the order of increasing frequency, decreasing wavelength, right? This is the order of increasing frequency and decreasing wavelength or the lambda, right? So with the help of this you can recall, and if you know another method to learn, that's good enough, right? So just remember, whenever you find some data and you're not able to recall it regularly, just make a mnemonic of it. In chemistry, it will help you a lot, right? Now further, with the help of this mnemonic, let's find out, not with the help of this only, if you are able to find it out yourself, it's good enough, okay? So when I'm just looking at here, that gamma rays with the minimum wavelength we have, and the highest wavelength, as already Jaidev has wrote there in the comment section, that radio has the maximum one, great, okay? So the answer for this question is here in front of you, the second option, and absolutely right. Inversely proportional, okay? Please write with frequency. So this is the mnemonic that I have mentioned beta here. Have a look, the study empire. what I did from radio to gamma, I've just mentioned here, right? And as you are moving down, the frequency is increasing and the wavelength is decreasing, right? Study Empire, I don't know your name, but I'll be using this name only. Study Empire, have a look on this. And the mnemonic is the ready for mic testing with irritating, very unpleasant xylophone and guitar. You make your own mnemonic. If you find that this is difficult, don't worry. Whatever suits you, prepare yourself. Okay? Otherwise, you can learn from it. Done? Shall I move forward? Just give me a thumbs up here. Full. Okay, thank you, Sudeep. See what is going on. So what we are doing, we are taking the questions from entire chemistry, and session by session we are trying to take all of the questions which are useful for you, right, Sudeep? So you have to join in the morning at 10 and 10 to 11, 11 to 12 continuously. We all are here to help you all, right? पूछ लेता है sometimes frequency की. So वो range आपको याद करना पड़ेगा. Study Empire, you have to learn the range, okay? Sometimes, but generally आपसे order पूछा जाता है. अगर आप पूछेंगे, हाँ, question is completed, Jaydev. Question is completed, right? So I'm moving forward with the next question. Okay, so I got the thumbs up from Sudeep, and I just assume that all of you are understood the previous part. Now I'm taking the next question. The question is question number 48 from the paper, and the question is maximum number of electrons in a subshell is given as, right? So when I'm talking about a particular electron present in an atom, so it's being assumed that there is a shell, then subshells are there, and further orbitals are there, right? Orbital is the space, the place in the 3D where the maximum finding probability of the electron is there, right? Answer is 4. I don't think, just check once again. Chirag and Manalika, please check once again. The question is about maximum number of electron in a subshell, right? So when I'm talking about shell and its energy, it's been represented by the principal quantum number n, right everyone? 4l plus 2, right Jaydev? Good, very good. Principal quantum number n represent the shell, right? And when it comes to number of electrons in a shell, maximum number of electron in a shell, what would be the answer? Maximum number of electron in a shell, that could be identified by 2n square. This is maximum electrons in a shell, Bohr-Bury scheme, right? Now if you know the shell, then you can find out azimuthal quantum number, right? The L value you can identify with the help of n, and that L value would be 0 to n minus 1. So if you know n value, you can find out L value. Now question comes that why we are finding the L value? Just to identify the orbital. If L value is 0, then it aligned with the s orbital. If it is 1, it's for p, it's 2 for d, 3 for f, and so on, right? Now the question was how to find out the number of electron in an orbital. So how to find out orbital? These are subshells, right? If I'm talking about first subshell, the s subshell, there is only one orbital. In p subshell, there are 3 orbitals. In d, there are 5 orbitals, and in f, there are 7 orbitals. The formula that we use here is 2l plus 1. This is the formula that we use for the orbital, right beta, right Jaydev? Study Empire and even Jaydev, you wrote there correctly the number of electron, the maximum number of electron in a shell, right? So these are the simple formula you need to remember, and you can solve the question. This type of question you will find in the NEET examination. In the previous year examination, such questions were there, and what we expect, that similar question can also be there in the upcoming examination, right? So keep solving questions. Okay, so 2l plus 1 gives me the value of number of orbitals in a subshell, right? And how many electrons are there in one orbital? The maximum number of electrons, those can be accommodated in an orbital are what? Just think. Only 2 electron, right? Am I right? Because p orbital, px, py and pz or the pz, right? One orbital can have 2 electrons. So in total, p subshell has 6 electrons, right? So the simple thing, if 2l plus 1 is the maximum number of orbitals in a subshell, then how many electrons would be there? Double of it. Double of it, right? 2. Yes, 2 into number of orbitals. So number of orbital is 2l plus 1 into 2. So 4l plus 2 it would be. And 4l plus 2 is not given, but in terms of this it is given. 2l plus 1 into 2. Right? And those who were writing here, the answer is 3. Those all are correct. Manalika wrote, I think. Manalika, earlier you wrote 3rd, right? And right now you were writing the number of electron in the orbital. I understood. Okay? Let's move. So, right answer you obtained, and the turn comes for the next question. Right? Is the concept clear? Though simple, but revision is required. Okay. Now, completed. Great. The next question is question number 49, that says correct order of decreasing negative electron gain enthalpy. The first question, what is electron gain enthalpy? So the simple definition, that you are adding an electron in the valence shell of an isolated gaseous atom, right? By providing energy, you have just converted an atom into isolated state, gaseous state, and then you are adding some electron to it. And while you are adding electron to it, electron has higher energy, it's moving, and you are just adding it into a shell. So there is a release of energy in the general case, right? But for the noble gases, whenever I'm talking about the electron gain enthalpy, that is positive. But for other element, option 2, okay, I have to just look at beta. Directly I'll not be saying. Okay, so, so negative electron gain enthalpy, that is maximum for a group 17 element. If you're just looking in the group 17, we have fluorine, chlorine, bromine and iodine. Then astatine is also there, but we are comparing these. Here, if you just look at the highest value, because if I'm talking about fluorine, that has more electronegativity as compared to chlorine. So it has the tendency to attract the shared pair of electron. But when it comes to electron gain enthalpy, it means that is an amount of energy release, or simple to say the enthalpy change when an electron is added to the valence shell of an isolated gaseous atom. So in that case, what happens? Though it is more electronegative, it will attract electron, but while it is taking electron, there would be interelectronic repulsion, right? Though nuclear charge is applicable there, but interelectronic repulsion will not allow it to have the maximum negative electron gain enthalpy, right? So when I'm talking about these two, the order is Cl the highest one, then fluorine, then turn comes for bromine and iodine. This is the order of negative electron gain enthalpy. Yes, yes beta. Because in case of fluorine and chlorine also the same reason is there. Fluorine small sized, interelectronic repulsion is too much, and that's why its electron gain enthalpy is less negative as compared to fluorine. Fluorine has the, this value nearly minus 349 kilojoule per mole, right? Yes. So this would be the order. Now same ways, if I'm just looking at the elements given here, oxygen and sulfur is also there. So we have to look at group 16 as well. In group 16, the first element is oxygen, then sulfur, selenium, tellurium and the polonium, right? So tellurium, suppose I'm writing here. My question, okay, no, see, polonium also I wrote. Now my question is, what about this group? So in this group also the similar trends being followed. Oxygen has small size, more interelectronic repulsion. So negative electron gain enthalpy is less in this case as well. But one more thing. Here what you found, that chlorine, fluorine, bromine, iodine. After chlorine, fluorine is there. But in this group, this oxygen has very less value of this as compared to the other element, minus 141. Right. For group 16, sulfur, selenium, tellurium, polonium and oxygen is in the last. Very good, Jaydev. Very good. Oxygen has the least value in this group. Okay, in the group 16. So some of the exceptions are there, those you need to remember. And this question is based on that only. Highest value is aligned with chlorine. So here is chlorine, here is chlorine. So these two options can be Correct. Then fluorine in both of them. Very right, very true. And when it comes to oxygen and sulfur, this is not correct. This is correct. Right? So if you're not able to remember the values, don't worry, but the trend, the order, that should be remembered. Okay? If you look at the previous year questions, you find that lots more questions were asked based on this order for the various groups. Okay? Done? And definitely this term is very important, negative electron gain enthalpy, because this represents that process is going on and this process is exothermic. While you are adding an electron, suppose chlorine you have, and you are adding electron to it to form chloride ion, negatively charged ion. So in this case, there is the release of energy. Energy I'll be writing, not heat exactly, energy. Now suppose I'm asking you one question that O negative and anion you have. One anion you have, and what you're doing, you are adding one electron to it to form O2 negative. What do you think? Is this process endothermic or exothermic? Any answer from you all? Suppose this type of question are also asked from this chapter. Is this endothermic or exothermic? Right, Jaydev, right. See, when oxygen was there, electronegative it is, size is small, nuclear charge is also helping it, though somehow the interelectronic repulsion is there, but still, whenever electrons being added to it to form O minus, then energy would be released. But now, when O minus is already negatively charged and you are trying to add one more electron, it lots of interelectronic repulsion, and that will not allow the process to occur easily, right? And that makes the process endothermic, right, Divya, Study Empire, Jaydev, Manalika. So those who are answering, thumbs up to you all, right? Keep preparing and keep it up your spirit, okay? Done? Shall I move forward with the next question? Now, next question, that is from the chapter hybridization is there in the question, right? And hybridization means chapter 4, chemical bonding and the molecular structure, okay? See, the question is ammonia you have, you are adding it to BF3. One adduct is formed, and what they are asking, that which statement is correct. So if you have studied NCERT line by line and solved the question, you know such type of question is there in NCERT book in the answers as well, right? There instead of BF3, AlCl3 is mentioned, and they just ask that what happened to the hybridization. What's the change in hybridization, right? So anyways, let's check this question. So which is true? They are saying that change in hybridization for nitrogen take place, change in hybridization of boron take place, then in both of them or none of them. This is the question, okay? Option 2, Sukanya. Maybe the answer. What happened in this reaction? If I'm talking about ammonia, pyramidal shape, one pair of electron is present here, right? Tetrahedral, this is the geometry. BF3 changes from sp2 to sp3. Okay, beta. Got it, Manalika. I got your answer. Now, what you are doing? You are just adding BF3 to it. And I hope everybody is aware that BF3 is an example of the incomplete octet as well. It has the vacant orbital, adduct formation, right, beta? So, vacant orbital this boron has. In that vacant orbital, this electron pair is being provided. So, this is one-sided sharing, or the covalent type of, covalent coordinate bond is formed, right? So, in that case, when it is happening, there is no change in hybridization of nitrogen because it is not losing its electron, it is sharing, right? So, this will continue with its hybridization. This is Lewis acid. If you studied, then you definitely know that this is Lewis acid and it is acting as Lewis base, right? And if I am talking about the coordinate bond, this is donor atom and this is acceptor atom, right? Dative bond formation. Why same question is repeating in exam? You did correctly this question, Tanmay. If you attempted correctly, maybe in the previous one there were more mistakes with respect to this question. That's why this question was provided again. That may be the case, because our aim just to help you to practice more on the concept in which you all are making mistakes, right? Very good afternoon. Very good afternoon. So those who have joined now, we are discussing the test number 6 from the AIATS Plus program, right Tanmay? Yeah. So this is about all the students. If more mistakes, more errors was there, because the target, if you're just looking at this, open discussion on frequently committed mistakes. So you find the questions based on the topics, or sometimes a similar question you will find, because what we want that the question in which you people are making mistakes are very much clear to you, they will get clear to you, and in the next examination you will not make such mistake, right? Okay, so this is Lewis acid, this is Lewis base. The hybridization of this Lewis base NH3 is same sp3, but BF3, if we just look at, this is trigonal planar, right? In the one plane all the atoms are, and what you are doing, you are providing electron pair to it. So its hybridization, which was earlier sp2, now get changed into sp3. So undoubtedly we can say that option 2 is the right answer, and Manalika, Jaydev, Tanmay, Kumaran, everyone who just wrote the answer correctly are going to definitely get the full marks here. And suppose in the NEET examination you find this type of question, you will get the marks. Okay. So the second option is the right answer, that change in hybridization of boron take place only. Please take a session on inorganic, 11th plus 12th. Okay. So I'll put this, the suggestion that you gave me. We'll try whatever we can do best for you all. Okay, everyone? Right? Let me proceed with the next question. The question number 51 we have. Right? Question number 51. Minimum bond order among the following species is of. The question from the chemical bonding once again. Right? And now you have several species, diatomic species you found here. And you have to just find out the minimum bond order for the following. So if you know the molecular orbital theory, you can easily do such type of question. And while doing such type of question, because the question is based on the species which are obtained or derived from N2 and O2, so I'm just writing here the configuration, molecular orbital configuration for this diatomic species N2. First of all, then for O2 I'll be writing. For N2 it is sigma 1s2, sigma, see how jumping I am to the next one. So sigma anti-bonding 1s2, sigma 2s2, sigma anti-bonding 2s2. Then what? After that, O2 minus has the bond order 1. Second option is correct. Rehana, I'm coming to the question. I'm coming to the question, right? So for N2 it is sigma 2pz. Then 2 electrons I'll be filling. How many electrons are filled? 10 so far, right? Then pi 2px. Yes, this is for N2, not for O2. Pi 2px, pi 2py, then sigma 2pz, then pi antibonding. So in total 10, 11, 12, 13, 14. This I filled, right? Just find out the bond order in this case. How to find out bond order? Here I am writing the formula. Half of the electrons in bonding molecular orbital minus anti-bonding molecular orbital. The electrons in anti-bonding molecular orbital, right? For nitrogen, if you find it out, that you will find it is 3, right? It is 3. So here N2 is not written. For N2 it is 3. Now further N2 plus if I am writing, then if N2 plus I am writing, what I am doing? I am removing one electron from sigma bonding electron, right? From the bonding electron, one electron I am reducing, right? So it will reduce the bond order by 0.5. So for N2 positive, it would be 2.5. 3 minus 0.5, right? So Divya, you wrote here correctly for N2 positive. For N2 it is 3. Very good, Manalika. Divya, for N2 positive it is 2.5 you have written here. Jaydev wrote for O2 minus, that has bond order 1. You are also correct, beta. Now for O2 it is bond order is 2. For O2, how to write the molecular orbital configuration. So first line would remain same for both of them. This is same here. Rather writing again, I'm just marking these two dots just to represent that same here. And now then turn comes for sigma 2pz, 2 electron, then pi 2px and pi 2py, and then pi 2px anti-bonding, 2py anti-bonding. This is for O2, and for O2 the bond order is 2, right? So what about O2 minus? Because 2 and you are adding now electron to the anti-bonding MO, 1 electron to the anti-bonding MO. It means bond order would be reduced, right? And how much it would be? Because in the anti-bonding molecular orbital you are adding 1 electron, right? So generally for O2 we count this way, half of the 10 minus 6. 6 electrons were there in anti-bonding molecular orbital, and in the bonding 10 electrons were there. So 10 minus 6, 4 by 2, it means 2 is the bond order for O2. And while you are doing O2 minus, it would be half of the 10 minus 1 electron extra here, 7, 10 minus 7, 3, right? And 3 by 2, 1.5. So this is 1.5. And for O2 2 minus, once again, this is how I am doing. 10 minus 8. It means 2 by 2, 1 it is, right? So all the bond orders I have just mentioned here. Easy to find. That O2 2 minus is the right answer, and lots of answers. The correct answers I am getting here. Rehana, Manalika, Divya, the Study Empire, and Jadev, and many more names which I was not able to read so far. All of you who marked it correctly, kudos to you all. Let me move forward with the next question, and what I'll be trying that to take most of the questions from this part, from this segment, okay? And some of the additional question I will also be taking, okay? Don't worry. Now, the question number 67 from the paper AIATS Plus, test number 6. Mass of HNO3 required to prepare 400 ml of solution. So the question is from the concentration term, and this time the concentration term is molarity, 0.2 molar, right? And I hope everybody is aware that how to find out molarity. Molarity is the number of moles of solute upon the volume of solution, and that should be there in the unit liter, right? 5.04. Great. Okay. So in this question, molarity is given, beta. 0.2 is the molarity, and that is equal to number of moles of solute that you don't know. While in this question, they just ask that find out the mass of HNO3, right? So if you know the mole, you can easily calculate the mass, right? How? By just multiplying molar mass to it. Okay? See, volume of the solution is 400 ml. 400 I wrote here, but it should not be in ml, it should be in liter, right? So, how much it would be? Number of moles of HNO3. HNO3 is the solute here. That would be equal to 0.2, and this is 10 by 4. So, that would be 0.2 into 4 by 10. So, 4 2s are 8. 0.08 mole of HNO3 we have, right? And the mass of HNO3, how much it would be? What's the molar mass of HNO3? Yes, right, Hilal. Mass of HNO3 is its moles into the molar mass. That's 63 for HNO3, 63 gram per mole, the molar mass of HNO3. Just multiply it. And you all are writing answer. And I know the answer, that is 5.04 watt. It's in gram. Nearly this you will get here. Right, Rehana. Okay? 63 gram molar mass. 63 gram per mole, beta. Units are very important, right? So, if gram molecular mass you are writing, then 63 gram it would be. But molar mass someone asks you, then 63 gram per mole. So, some of the things you need to remember. Right, Hilal? Tanmay? Answer 1 आया था मेरा. Great. Very good, Tanmay. So, option 1 is the answer. +4 to you. +4 to you all who got the right answer. Done? Now, in the continuation, I'll be moving forward with the question from the chemical kinetics. So, chemical kinetics is also the part that we need to look at, because the simple chapter, easy chapter, every time you will find the question with respect to the rate of reaction, with respect to the comparison of the rates. Simultaneously, Arrhenius equation is very important there, right? How the rate constant be affected by the temperature, that can be the question. Various orders of the reaction, the first order reaction, the zero order reaction, their half-lives as well, right? So, these are the core concepts from which you find the questions. Okay, Manalika, third option. Maybe, let's see, if we plot a graph between log k and 1 by t for Arrhenius equation, the slope is. So, what Arrhenius equation is? K is equals to Arrhenius constant A is this right, Monalika? Manalika, not Monalika, Manalika. So, J, option 3, okay. Now, if you are taking the log, then it would be log E, log EA minus EA by RT, and instead of taking the natural log, if you are taking the base 10, then it would become here 2.303, this way. Done? Now, compare it with this equation of the straight line, y is equals to mx plus c. So, at the y-axis, you have to take log k here, and at the x-axis, because in the question also they just mentioned that you have to plot log k with 1 by t, right? So, just take 1 by t here. Then the graph that you will be getting in this case, y is equals to mx plus c, and if 1 by t is representing x, then slope would be minus EA by 2.303, right? It means negative slope you will be getting, and the slope would be minus EA by 2.303 RT, because you are plotting between log k and 1 by t. Not t, I am sorry, t should not be here because t we have taken in the on the x-axis, right? So, this would be. What is the intercept in this case? Yes. What is the intercept in this case? Intercept. This Arrhenius constant value you can find out by the graph using intercept. Done? Okay. So, answer I got here is option 3, the negative slope in this case that you will be getting, right? Okay. Now, let me move forward with few more questions. Definitely we have to take log E. Yes, yes Divya, yes Tanmay, Manalika, everyone. Okay. Next question, the question number 72. The half-life of a first order reaction is 10 minutes. The time required for the concentration of the reactant to fall from 2 milligram per liter to 0.25 milligram per liter. Easy question. I was right with the third option. Yes, Hilal, you were absolutely right. ln hota tab second hota. Yes, bilkul, bilkul, absolutely. If natural log was there, in that case second option hota. Minus वो EA upon 2.303 R, वो नहीं होता, right? If ln was there, that term 2.303 would not be there. So, this shows that you are studying well, okay? Now, half-life of a first order reaction T half is given. What's the relation between T half and K? T half and K, T half is 0.693 by K for the first order reaction, because in the very beginning they have just specified first order reaction, right? Now, K you can calculate with the help of this. What's K here? K would be 0.693 upon what? Upon 10. And the unit for the same would be minute inverse, because time was there in minute. Okay? Good, good Divya, Divya and Manalika. Tanmay T 87.5% पूछा है, I guess. That can be there, right? Absolutely. That way you can also proceed in the question. Otherwise, by this using the simple method also you can work. So K you have. So further they ask that the time required for this conversion from 2 milligram per liter to 0.25 milligram per liter. So that is also easy, that the simple formula for the first order kinetics 2.303 by K log R naught upon R. Am I right? This equation we can use here, right? 30 minutes I have to look at. The K value is 0.693 by 10, 10 will come here, log R naught was 2 milligram per liter. The same units were there, so that's why I am writing in the same units, 0.25. So this is 200 by 25, right? And 25 8s are 200. So this would be 2.303 upon, I am not multiplying because some of the things will cut simply, into 10 log 8. Log 8 means 2 raised to the power 3, right? And that's 2 raised to the power 3 can also be written as, I am rewriting it, that can also be written as 3 into log 2. And do you know the log 2 value? If you don't know, then you need to remember the log 2, log 3, log 5 value. Learn that. Okay, so that's easily you can put there in the question. So log 2 is 0.3, 0.3010, so directly I am taking 0.3. Done? Now just see, this 3 into 2.303 is nearly equal to, I will be multiplying these two. So what I will be getting? These two. Nearly 0.693 I will be getting, right? When I am multiplying this. 0.3 into 2.303, right? So these two will cut. And last 30 minutes you will be getting. Right? That's it. And 30 minutes is here in the fourth option. So whenever you find such type of question, just do remember that how to find out K, the kinetics equation that you derive from the integrated rate law, you can simply say. Use that, put the value, get the answer. Okay? Simple? So I am moving forward because all the question I need to cover over here. Okay? So question number 90 from this paper, the last question it is. The mole fraction of acetone, the question from the concentration term once again from the very first chapter, and in the chapter solution also you find this type of question. Okay? So the mole fraction of acetone in ethyl alcohol is 0.3. Then the molality of acetone in the solution is. So what molality is? Small m we represent. The molality is represented by small m, that is moles of solute divided by the mass. And which mass we need to take? Mass of solvent. And it should be there in the unit system kg, the SI system we use. Okay? Okay? All session chapter wise, all subject. Okay. Done. I have noted your query as well. Fine? So, you have ethyl alcohol and its mole fraction is given. So, I hope everybody is aware that mole fraction represent that if two components are there, then chi A plus chi B is 1, right? And if A is this acetone, right? And its mole fraction is 0.3, then what about chi B? Definitely it would be 0.7, then only we will be getting 1, right? So this we got 0.7. This was acetone and this is ethyl alcohol or ethanol I will be writing. This is for ethanol. Done. Now let's solve the question. For the molality you want the moles of solute, so that I am taking directly 0.3 moles of solute, 0.3 divided by you want the mass of the solvent, and now what I am considering in the larger amount, this ethanol is given 0.7 I can take here, its mass, its mole, and its mass would be mole into molar mass. The third question on the same thing we are getting, that mole into molar mass will give you the mass, right? So mole I have taken, the molar mass of ethanol is ethanol C2H5OH. How much is the molar mass for this? 46. 46 gram per mole, isn't it? This way, just solve this. 3 by 7 and further divided by one more thing, one more mistake, because this you will be getting in gram and you want this in kg, right? So I'll be multiplying 1000 here as well. Now solve this. Now solve this. This would be 3000 upon 7 into 46. Solve this, and if you solve this, you find, don't use calculator, try to solve yourself. Try to solve yourself, you will find that this comes out to be 9.3 molal. This would be the molality, right? Right, everyone? Just check once, not 8.3 Manalika. Just solve, you find that 9.3 is the answer. Okay, Divya? 8.3. So that I need to look at. Just check once again. Just check. So this I am leaving to you all. Just solve this and find out. Okay? Achha, you did a calculation mistake. Okay. Just solve this value. I am just enclosing it. Find out the answer. Okay. Fourth option, right? Here. Just check. Just check. Great. Great. So 9.3 molal I am writing, but still the question, the ball is in your court only. Solve it, find it out. Okay? And try to use your calculation skills rather using calculator. Okay? Good. Okay, Divya, you got this answer? Great. Now I'll be taking one more question in the continuation. You gave me the first answer, right, Hilal? I know, you have already given the answer. Even most of you have given the correct answer, but sometimes some of the calculation mistake, but that you need to avoid, okay? Now, this question I have just taken from some other previous year question. So, percentage of the magnesium you have to, this type of question will also be there. This is based on the percentage calculation, right? The percentage of magnesium in biomolecule, mass percentage calculation or the concentration term you did in the first chapter only, and based on that, percentage of magnesium in a biomolecule is 0.2% by weight, and the minimum molecular weight of the biomolecule you need to identify. So, the students who are here from the Aakash, the Aakashians know that this type of question is there in the study package as well. The simple question, but it seems you are Aakash offline student and you get AIM 720 series as well. Great, beta, great. You will find lots of questions and the concepts, important concept with respect to your upcoming examination. Let's solve this question. Magnesium is present in the biomolecules and everybody is aware that biomolecule can contain magnesium. Maybe if I am talking about the chlorophyll that contain magnesium. Same way, suppose I am talking about the hemoglobin that contain iron. So, with respect to that, we don't need to remember that biological part, but definitely in this question, how to proceed, let's check. So, magnesium has the percentage 0.2%. What does it mean? It means if biomolecule is 100 gram, simple comparison I am doing. Okay? So, 100 gram of biomolecule has how much of the magnesium? 0.2 gram, right? This is the simple interpretation from it. Now, suppose your biomolecule you have at least one magnesium atom you have there, right or not? In a biomolecule, at least single magnesium atom you would have, and that single magnesium atom has that 24U. This is the atomic mass, right? 24U. So, instead of 24, instead of writing 0.2 gram, I am using the same unit. Instead of taking 100 gram, I can take this way, right? So, if 0.2U is the mass of magnesium, then mass of biomolecule is 100U. And now, if it is 24U mg, at least one atom of magnesium should be present there, na? So, 24U magnesium will contain will be present there in the biomolecule. So, in simple unitary method I am applying 100 upon 0.2 into 24. So, this would make 12,000 U. This is the minimum molecular mass of the biomolecule. At least one atom of magnesium should be present there. So this will give me the minimum molecular mass of that biomolecule, right? So this 1.2 into 10 raised to the power 4. This is the minimum molecular weight, right? So Devil, 777, you are asking about the PDF. So would be good that you just continue with the program, and while I'm solving question, you just try to solve the question, right? So you don't need to look it back again, because there is no lot more time that continuously you are revising the previous content which has been done, right? Better to go with the simultaneous manner, right? Okay, fourth option, I have just marked. I trusted you and I marked here, though I have calculated here as well, right? So this way, the questions from the paper I have taken, one additional question also I have taken, and this program will be continued here onwards. You will find one more session. Stay tuned here. The session would be continued here onwards, right everyone? Till the time you just get a glass of water or tea, coffee sometime, and definitely you will find some more concepts, some more questions to enhance, to be completed with your upcoming NEET examination, the preparation part specifically, right? So keep preparing, keep learning, okay, right? Okay everyone, thank you so much, bye-bye.